This is part 1 of our array patterns series. Suppose you need the sum from index 2 to 5. You add 4 values. Then another query arrives, and you add many of the same values again. The array did not change, so why repeat the work? In this lesson, we will build one extra array and answer each rangeSum query in O of one time. For one small range, direct addition is fine, but a query may scan almost the whole array, so it can take O of n time. With Q queries, the worst case grows to O of n times Q. The waste is easy to see. Overlapping queries keep adding the same values. We need to save that work once and reuse it. Start with 5. Add the next value and the total becomes 8. Add 8 and it becomes 16. Each new total reuses the previous total and adds only one number. These cumulative totals form a prefix sum. We will place a 0 before them. Then prefix at I means the sum of the first I values. That one extra 0 gives every range the same formula, even when the range begins at index 0. Now build it. Prefix 0 is 0. For each input index I, take prefix at I and add nums at I. Store the result in prefix at I plus 1. The first step is 0 plus 5, giving 5. The next is 5 plus 3, giving 8. Then 8 plus 8 gives 16. The same rule completes the row. We scan the input once so the build takes O of n time. Keep one meaning fixed. Prefix at I is the sum of the first I elements. Prefix 6 is 26 because it contains original indices 0 through 5. Prefix 2 is 8 because it contains indices 0 and 1. Once this boundary meaning is clear, the range formula becomes simple. We want the sum from index 2 to 5. Prefix 6 contains everything from index 0 through 5, 26, but it also includes the values before our range. Prefix 2 stores exactly that unwanted part, 8, subtract it, and only indices 2 through 5 remain. 26 minus 8 is 18. For any inclusive range, the right boundary is right plus 1, and the left boundary is left. So the rangeSum is prefix at right plus 1 minus prefix at left. It is simply a larger prefix with the unwanted prefix removed. For 2 to 5, prefix 6 minus prefix 2 gives 18. For 0 to 3, use prefix 4 minus prefix 0. Because prefix 0 is already 0, there is no special case. For the single value at index 4, prefix 5 minus prefix 4 gives 7. The same formula handles all three ranges. The prefix array takes O of n time to build and O of n extra space. After that, one query reads 2 prefix values and subtracts them, so it takes O of 1 time. With Q queries, the total is O of n plus Q instead of O of n times Q in the worst case. This trade-off is useful when the array is mostly static and range queries are frequent. The code follows the same boundaries. Create a long prefix array with one extra cell. For each I, prefix at I plus 1 equals prefix at I plus nums at I. The range function returns prefix at right plus 1 minus prefix at left. There is no special case when left is 0. The common mistake is using right instead of right plus 1. Remember, prefix at right plus 1 includes the right element. Prefix at left removes everything before the range. Use prefix sum for repeated range totals in a mostly static array. The same cumulative idea can store counts and frequencies, and it becomes the base for subarray and two-dimensional grid problems. But if values change frequently, the prefix array may need rebuilding. That is when other data structures become more suitable. The mental model is simple. build cumulative totals once. Prefix at I stores the first I values. For an inclusive range, subtract prefix at left from prefix at right plus 1. That gives O of 1 time per query after 1 O of n build. Prefix sum is not about adding faster. It is about never adding the same values twice. This was part 1 of our array pattern series. Next, we will combine prefix sum with a hash map to solve subarray sum equals k. Try the pinned comment question before you go.